Hello, welcome to your technical interview. I'll be conducting your interview today. Let's start with some theoretical questions. What happens internally when a CI pipeline is triggered after a code commit?
Okay, so this is about the CI pipelining workflow. When a commit is pushed, the CI system pulls the code, install dependencies, builds the application, and runs automated tests and reports the results. CI tools like Jenkins and the GitHub Actions are webhooks to detect commits. So the pipeline ensures code quality by automatically validating changes before merging. This also includes webhook-based trigger, code checkout, and the automated feedback.
Great job! You covered the key points about the CI pipeline, including the webhook trigger and the importance of automated feedback. Your understanding of the process is solid. How do Kubernetes services enable communication between pods?
I have a brief idea about Kubernetes. It is a comprehensive open source orchestrated platform that automates the deployment, scaling, and the management of containerized applications. Um, but I still can't get a question. Can you please clarify the question again?
How do Kubernetes services facilitate communication between pods?
Okay, so Kubernetes services, um, I don't know much about them, but I still know that they provide a stable virtual IP and a DNS name that load balance traffic across multiple pods. I know that they provide stable IP and DNS, including load balancing and abstraction. It's I just have a rough idea about the Kubernetes. So yeah.
You did well mentioning the stable virtual IP, DNS, load balancing, and pod abstraction. It's great that you have a foundational understanding of Kubernetes services. Keep exploring these concepts for a deeper grasp. What is the difference between a Docker image and a Docker container, and how are layers used in Docker images?
Okay, so the Docker uses the host operating system kernel rather than the virtualized full hardware layer and the guest OS. So the Docker image is a written blueprint. That is the read-only blueprint template used to create containers, while a Docker container is a running instance of that image, the live instance of that very particular image. So the Docker images are built using multiple layers across the entire framework, where each layer represents a change. The Docker image consists of multiple immutable layers that can't be changed and can be created using the Dockerfile instructions. When a container is started, a writable layer is added up to both of the layers. So that does allow changes to modify all the content that was mentioned in the Docker image. Image is the template, and rest the work is entirely based upon on the layers.
Great job. You clearly explained the differences between Docker images and containers, as well as the concept of layers in Docker images. Your understanding of immutable layers and the writable layer added when a container starts is impressive. Thank you for completing the interview. Your responses have been recorded.